Okay, let's discuss. And what I said, the important part here was you have something to remember, right? So again, this is the important thing. So u dv equals u v minus v du. This is super important to remember this, all right? So what I want to do is look at this problem over here, and I'm kind of looking for something that looks like this over here. And there's two selections to make. And by the way, I'm not going to say it's going to be easy to make those selections, but you're going to have to try. You need to make a selection for u and a selection for v. All right, let's write that down. So I'm going to say, just looking at this guy over here, that I'm going to say u is equal to x. And if I do that, I'm going to write that differential down, du. Now, someone says, why do you do that? I need that. And what's du going to be? dx's. If you said u is equal to x, though, what you're saying is, you're saying that dv is equal to e to the x dx. This creates a problem, by the way. This selection should be made so you can actually do it. And what are you actually doing? You're actually doing an integration, and a simple one. You're looking for the antiderivative, all right? So v and e to the x. And why is that? Well, the differential of v is dv, and the differential of e to the x is e to the x dx. So it works out pretty good. So what I'm going to do over here, again, I want to be clear about this. I want to make sure you know that this guy over here has something to do with this over here, with this information over here, right? I'm going to write that down now, and I'll write down as an integral. What's u is x. What's dv? It's e to the x dx equals, and again, we're just looking at this over here. What's u? U is equal to x. What's v? It's e to the x. Again, we're looking at these things over here. Minus, well, what's v? It's e to the x. And what is du? Du is dx. Okay, the big question is this now. This is what they asked me to do. The question is this an easier integration? And in fact, it is easier. So I can actually do that, right? So what do you get over here? X, e to the x, minus, well, what's the antiderivative of e to the x? It's just e to the x. Once I remove all the integration symbols on the right-hand side, I put the constant of integration down, which is going to be plus c. Are we getting what we got in the original problem that we introduced today? Of course we are. We're getting the same thing. Things work out nicely. Okay, so what's the big issue over here? Identifying what you have as being a product, and the product you're looking for is you're looking for a u, and you're looking for a dv. So you're looking for a u, and you're looking for a dv. My recommendation to you is this: try. However, you should always be taking a dv where you can do the antiderivative. If you're picking a dv where you can't do the antiderivative, that would not be a good idea. However, there are subtle tricks over here, and what I mean by that, a lot of times we do write down a dv where we have a very difficult time finding the antiderivative of that. Well, you may want to switch around and try something different then, all right? Again, derivatives are easy. Taking the antiderivative something can be very difficult. We're going to try. At first, we'll give you suggestions, just like we do with u substitution, but later on, you need to make your own suggestions to get through it. Thank you.